This is good.
Yeah,
I think people are going to learn stuff.
Yeah, I hope so. I'm most excited to talk about test design and buddy system. I'm really excited about those. Hello and welcome to the Open Hardware Manufacturing Podcast, the podcast about making open source hardware. My name is Stephen Hawes.
And I'm Lucian Chapa.
And today we are talking about quality control checks, making sure that the things that we send out the door are actually what we want to be sending out the door. This is a beefy boy.
Oh, yes.
There is a lot going on here. It is a huge percentage of what we do here every day to make sure what we're making is correct. For every product that we make, there's the whole secondary product, which is how we actually check to make sure it's right.
Yeah, in this one we discuss a lot of our mentality around QC, how to think about it, how to regard it, what threshold should be for risk. We talk about how the best car is a teleporter.
That is true. We talk about Ben & Jerry's and how they do QC, which is really, really cool, and how they use AQL, which is something you should probably only think about when you're making a ton of stuff. I would definitely not get hired to make a Lumen today because I'm very slow and I made a lot of mistakes building on the line when I built cable chains recently, which is hilarious. And it also kind of makes sense when we get into that. We talked about our change to our QC process where we add QC buddies because you kind of get blind to the mistakes you make. And that's also kind of why I made the cable chains wrong. We talk about traceability a little bit too, and how you should kind of be thinking about how deep you should go with traceability for your QC checks. And also a little bit about Gundam, which is our full test suite for testing stuff QC. There's a lot in this. QC is not a simple process. It takes more time than... Do you think we've spent more time designing QC steps and processes than we did the Lumen? The fact that we're even thinking about that says a lot about how important this is. This is an incredibly important topic.
It stops you from shipping something bad.
Yeah.
QC protects your reputation. It protects product integrity. It's so critical. It's not optional.
Yep.
It needs to be taken seriously.
It's the whole second product.
Yeah. I don't know if we spent more time on it than the Lumen, but the time spent is more important than designing any given part. The ROI on it's huge.
It's incredibly important. So yeah, there's a lot in this one. So much, as always, whenever we have one of these topics, it's it depends. It depends on what you're making, but there's some pretty good ground truth things that I think we've learned from having done this for a little bit and from our experience at Forum Labs too.
Yeah, so we're looking forward to it. Hope you guys like it.
Yeah.
Let's get into it.
Let's do it.
So to us, a big thing when talking about quality control is mentality. How do we think about it? How do we regard it? And for us, it's really an exercise in figuring out what do we need? What is our threshold for risk? Really, I think of it as we can always QC test more. But it's also a resource. We don't want to use too much of it. We don't want to use too little.
Yep.
We have to strike that balance.
Right. It almost kind of reminds me of GD&T, which for those who don't know, it's GD&T is a very thorough methodology for dimensioning a mechanical engineering drawing to make sure that you're only getting the precision in the places you care about. If you say, hey, this part needs to be accurate to 10 thou, that part's going to be egregiously expensive and you probably don't need it to be that precise everywhere. But if you're hey, I only need it to be 10 thou flatness on this face, and it needs to be perpendicular to this face, your cost goes down a ton and you still get the quality you need. So it's you need to decide exactly what it is that you need to check to accomplish the goal that you want to accomplish.
Exactly.
Yeah.
At the simplest example, I ask a technician to stare at the top side of a staging plate we ship for 20, 30 seconds, and the underside, inspect it for scratches for 10.
Yeah.
It's staring at the bottom side that a customer never sees in a finished machine. It's just quality you don't need.
Right. Exactly. And also another thing that we think about a lot too is there's nothing worse than shipping something bad for so many reasons. It sucks.
Yeah.
We dropped the ball. That is the worst thing.
Yeah. To test anything for an amount of time has a cost associated to it, but it pales in comparison to shipping something built wrongly, both in the cost to ship something else in material, brand hit. It's just not acceptable.
Yeah, someone being bummed, if we want to go back to the whole what's the mission is to help people make their products. It's the antithetical to that is to send them something that doesn't work, so it always makes more sense to spend that time to test and make sure that you're not doing it. So that's another thing we keep in mind a lot as we go through this and decide what to test and how. We're just trying to make sure that something is not leaving in a way that we didn't intend it to.
Exactly.
So one of the first things that we implemented QC testing for was our PCBs, because it's something that we do custom here. We design them, we don't fab them, but we populate them on the Lumen, we put firmware on them, we do all kinds of stuff with our PCBs. And we learned the hard way of QC testing our boards and how much to do it when we started doing our Rev 4 motherboard, where we were doing all of our through-hole soldering ourselves. Because in the early kits, we just did surface mount. And It was so tough because the way we would test them was we would do our surface mount reflow on the lumen, and then we would immediately then go and solder all our through hole. And then we'd slap it on a staging plate, put it in a machine, and test a machine with the motherboard. Well, there were soldering mistakes with the through hole soldering. We didn't check after through hole soldering and before we spent all this time plugging stuff into it, mounting it on a machine. So we ended up spending, oh God.
We got our butts kicked.
We got our butt. There was I remember there was 1 week in particular where I walked into Ghidra and you and Bryce were just crestfallen. And you were like, we've taken apart 5 machines in the past hour because there was a tiny little soldering mistake.
Yeah.
And then I think that night, you and I just pulled an all-nighter and made a whole new testing setup for that motherboard to happen after a through hole, but before we mount it onto a staging plate. Now it's the easiest thing in the world. They always are because we test them before they go on.
Right. We have a mentality there as well. It's we don't let the motherboards leave the SMT line unless we know they're good.
Right. Yeah. Mendel is the name of the room where we do all our SMT and through hole too. And if it leaves Mendel, it's perfect. It's been tested. It's been programmed. You can forget about that. If it's still in the room, it's up for debate.
Oh, yeah.
And that's a really nice, clean delineation of if it's out of the room, it's ready to go. It's been tested, all that kind of stuff. So that helps a lot too. But yeah, so PCBs are a huge, huge part of it. Tearing it down, even though we literally add that extra test for every motherboard, and a lot of them pass now without that problem, the amount of time it takes to tear it down is so much. It pays for all of the extra time testing those other ones,
Yeah. Even if it feels wasteful, you can test 100 in a row and maybe they're fine. And you're like, why did I just do that? Because you want to prevent issues from rolling downhill.
Exactly. What if there wasn't one? So PCBs are a really, really big thing that we spend a lot of time QCing in many different ways. But yeah, we used to do a lot of unit tests, which is kind of my way of saying we check to make sure one pin has continuity to another pin, with a pogo pin jig. And that's tough because that's not actually checking what the customer cares about. What the customer cares about is, does my X-axis move? Does homing work? Do my vacuum sensors give the correct value? Those are the actual pragmatic, that is what they care about.
Right. So it's important then to break it out into functional real world testing.
Yeah.
Yes, these pins on the stepper motor driver work correctly, but what about when we plug a cable into the DHT connector and the stepper motor's on the other end?
Exactly.
You might see differences. You might see things you didn't consider.
Right. So I think something that we've learned as time goes on is every test that we do on something should be as close to the real world example as humanly possible of what it's actually going to encounter. Maybe there's some things that aren't quite that way and we have to kind of unit test and extrapolate out that its functionality will work.
We do our best within reason here. When a motherboard's tested, we have it connect to as many stepper motors as it needs to, but those stepper motors aren't under load. But when we test a Y gantry assembly, we put a weight on the Y gantry that represents the mounted X gantry.
Right.
We pick and choose where we deem it to be important.
Yeah, so we try and we've been moving closer to that. And as we're thinking about replacing that pogo pin jig for testing motherboards, it's going to be all functional. It's going to be does it spin the motor? That's going to be the thing we check, not does this pin connect to this pin? It's fine, but it's not testing what you actually care about. And spending some time considering that, I think, is pretty important.
Yeah. The best QC check gives someone complete assurance, maybe even passively, that something was put together the right way. They don't have to doubt it. You don't have to have concern or lose sleep at night because, it went through the jig, it passed.
Yeah, exactly. Yeah. Yeah. I think we were talking about this before in the last episode about testing feeders and how I wasn't at the office for a while. And it was there was a little chunk of my brain that was in the thing. If your QC process feels even if it's just a rote execution of the thing, it should be so foolproof that you just know if it passed the process, it definitely has that thing in it. And there's only so much you can do about that. Count how many of these zip ties are on this rail. Is it technically possible to count them wrong? Yeah. But at some points, you just have to trust a little bit too.
Yeah.
So yeah, that's a bit about PCBs, switching more to functional. When we choose what we test, we check pretty much every single thing that we're expecting it to do. So I actually have a list for every PCB of these are all of the expected outputs and their specs. And whenever we're making these tests, we make sure that the QC check, when we write up that list of all the things we're checking, we make sure it's all of the things we're ever expecting that board to ever do, which seems pretty logical, but having that list written out is super important because it's pretty easy to forget about things on it,
Yeah. How did you decide to test PCBs the way you did? What made you aware of pogo pins or any these mentalities. I think we took a lot of good reference from like Winter Bloom and things we'd seen in past jobs.
Yeah, our devs mainly. Like when I started working on it, I was talking with, I don't think Thea was a dev at that point yet, but David Smith, who's one of our awesome open source devs, he spends a lot of time working on test jigs. I actually have very detailed notes from a conversation I had with him about that process. His implementation is definitely better than mine of how I did it for that first pogo pin. But yeah, I think we got a lot of influence from like how other people did it. The way that Thea does it is similar. It's like a bed of nails test, but it's more functional. And that's kind of why I'm leaning more that way, is from conversations with Thea of like, yeah, it should be a more functionally leaning thing. It should be more about, does it do the thing it's supposed to? That's really what matters. Who cares if the pin's connected? If the chip is busted, doesn't matter. It doesn't mean anything.
Right on.
Yeah. So I think that's probably where we got most of that. And it's changing over time.
It always does.
Yes. Yeah.
All right. Before we get to the next section, we're going to take a quick break for an ad. Stephen, take it away.
All right. This episode of the OHM podcast is sponsored by PCBWay. PCBWay has been our go-to for getting test boards made for any kind of fixture in-house or prototyping a new version, mainly because they are so fast at getting a board turned around and back to us, and sometimes we ask for some weird stuff from PCBs. The feeder itself has 4 PCBs in it, and they're all very strange, and when we sent out prototypes to PCBWay for all of them, they didn't even bat an eyelash. They just made them, and they were really quick. We got them in, we were able to validate them very quickly, and turn around and go into production with them. Thank you so much to PCBWay for sponsoring this episode.
So, as I said earlier, a large part of quality management and quality control is the jigs you use.
Yeah.
To me, a good assembly jig is involved here too. Ideally, a good assembly jig only lets you build something the right way.
Yeah.
Like on our X gantries, we have a belt loop that the Z carriage pieces mount to, and we have a jig for it. You can seemingly only put the pieces in to the right spot on the loop.
Yep.
We don't have to QC check that loop nearly as thoroughly because you could only have built it the right way.
Right.
Like,
there's only one possible way for it to have gone together. It's like it's kind of implicitly QC'd as it's been assembled.
yes, someone could be a bad actor and skip using that jig, but something else would fail. A future further down quality check would fail, like Z gantry homing.
Yeah. We still don't assume that it's right. We maybe don't have an explicit check for it because it's so much less likely that it's actually a problem. We're okay catching it much further down the road, and maybe it's a little more rework, but it's just, that's the time trade-off, you know?
Yeah, exactly.
Yeah.
It would be redundant and expensive to check something there when we shouldn't need to.
Right. And that's called pokeyoke? Is that the name of the phrase?
Yeah, it's from like the Kaizen, like Six Sigma Japanese production like mentality. It's just a phrase borrowed from there. It's to put things together and only let there be one way to do it.
Right. So like if there's a hole pattern that is, you could mount one thing to another with a hole pattern, and you could also do it 180 degrees rotated, like it's radially symmetrical. That's not pokeyoke, because you could put it on backwards.
Yeah.
Unless, of course, it doesn't matter which orientation you put it on. And then that's back to pokeyoke.
Yeah. Maybe it's a small detour, but I want to quote Sandy Munro. I think I've said this quote before, but the best process is no process. The best jig is no jig. The best check is not needed.
Yep.
So like, really do consider your parts and the designs of them and like try to make it only go together the right way so that like you couldn't do it wrong.
Right.
That's harder with SMT. Any part can be installed backwards, but
Sure.
when it's like a 3D printed part interfacing with another, certainly there's room to figure it out and get really smart.
Sure.
But yeah, ultimately the jigs in quality are about checking that you put things together right. An example that's kind of fun is with feeders on our production line. There's so many different permutations of things you could mix up.
Yes.
We have these fiducials on the front so that one day in the near future, you could conceivably scan the feeders with the top camera and see what size they are.
Right.
Like OpenPMB has no idea what size a feeder is. It just knows that it's a feeder is in the slot.
Right.
It is what it is. But we install these fiducials in the hopes that one day we can get support for like a camera scan that tells you which feeder is which.
Sure.
Now, the 8mm feeder and the 12mm feeder have the same size slot in the printed frame for the fiducial.
Yep.
Our fiducials are eerily similar.
I think it's literally 2 little fiducial dots on the PCB are 0.5 millimeter different in spacing. Like it's imperceptibly, they look the same.
Yeah. If you're staring at them real close and you're taking your time, you could tell they're different. But if you're holding a 12mm by itself, you can't really tell me if it's an 8mm or not.
Right. Yeah.
So we needed to make a quality jig that tells you which width the fit is and checking that the frame has the right one installed.
Right.
Think about how devastating it would be if we didn't control that well.
Yeah. Yeah, no, it would be a nightmare.
Yeah, that's a good example. We have all sorts of different little things around the production line.
Well, what's the jig that you made for that?
What we ended up making was a piece of plastic that sits in the feeder atop it with a positive feature that can slip into the pick window.
Mm-hmm.
The pick window for each feeder is a little bit different based on its width. So it fits in the 12 mil pick window, and I heat set 2 needles into the print. So it points at the fiducials when they're the correct width.
Yeah.
So you take this jig and you try to put it on a feeder, and if it doesn't fit, you made a 8 mil feeder with a 12 mil fid. And if the jig fits, but the needle doesn't point at the right spots, you made a 12 mil feeder with an 8 mil fid.
Right. Yep. Which is, but like we need some way to check that.
Yeah.
You know, we identified that early on as like, oh, this is so ripe for confusion. It's the ability for this to happen is so prevalent. We need to put a QC check in place for that.
And we hemmed and hawed about how we affect the process. Like, is there a vault where the 8 mil fids are locked up while 12 mils are being built?
Right. We talked about like a lock and key system where there's a tray of all the 8 mil parts and 12 mil parts, and you could only remove one at a time. So it's impossible to have 8 and 12 millimeter feeder parts out at the same time. In order to remove one, you have to insert the other.
Yeah.
Like crazy, weird stuff.
And just that level of mentality ended up feeling really wasteful.
Yeah.
Turns out the feeders are nearly the same. It's worth making 8 and 12s at roughly the same time. You're doing the same steps to all, and the frames just happen to be different alongside the fids.
Right.
So we had to make it conducive to like a mixed material workflow.
Right.
So,
And also to help alleviate this, we actually just last night we were talking about this. The 12 mil fid, because it's so hard to tell the difference, we up-revved it to have a silkscreen marking that makes it way more obvious what the difference is. Specifically for QC, we cut a new release of the board to make QC easier. So like changing your design to make it easier and more obvious. I mean, so many of the features in the Lumen you have made to make it easier to check and be like, oh, this is made correctly.
Yeah.
And the PCB change, it's the same thing. It's like, it makes it very obvious if something is wrong.
Yeah, there's nothing wrong with evolving your design to make a jig or a type of check redundant.
Yeah.
Not needed, vestigial.
Yep, totally. Oh, who's Sandy Monroe? You mentioned that quote. I'm not familiar.
He's a fascinating, I call him educator in the automotive community. He has an awesome YouTube channel called Sandy Monroe Live.
Okay.
I think he's gained the most fame lately for being the guy who does a teardown of each release of a Tesla, even by model year. Like every time the Tesla is refreshed, he will tear down the car.
Wow.
Cost it out. He will create their BOM. He will do a DFM analysis on it. He will tell you probably within 5-10% what it cost Tesla to make that car. He's like reverse engineering their PLM. He's noticing how the car changes to the smallest minutia between revisions.
That's insane.
Yeah. And it's fascinating. Like, my favorite video from him that I'd seen, I haven't watched him in a little bit, but his Model Y teardown. He tells you about like how the heat exchanger works as well as it does, and it's borrowed from SpaceX tech.
Wow.
Cool stuff. Yeah. He's a brilliant guy, and he has a lot of opinions about manufacturing in the automotive industry.
I bet if you tear down a Tesla a year, at least, probably 3, you know, like you probably have a pretty good understanding of like how cars are made.
The guy's educational enough that like Elon learns things about Tesla by watching his videos. Like he's been on his channel a couple times.
Really?
Yeah.
That's wild.
They're like friends now.
That's wild. To have someone tearing down your own stuff and tell you about yeah. That's wild.
And again, he says, best parts, no part. Best process is no process.
Mm-hmm. Just making it obvious, intuitive, and just the only possible. That's kind of poke to its, probably butchering the pronunciation. That's usually just how I say it, but that's taking it to its utmost extent.
To the end, yeah.
Yeah. That's really cool.
The best car is the teleporter. There you go.
There you go. It's no car. Needed. Yep.
So
the best car is a teleporter.
Yeah.
Yep.
So that's a physical jig that's checking assembly.
Yep.
Stephen also recently greatly improved one of our programmer jigs to serve as a QC equipment.
Right. Yeah. So when we ship lumens with slots attached, which are the little PCB print assemblies that bolt onto the front and back rail that let feeders talk back, we have to program every single one of them. And there's 50 in a machine. So there are 50 opportunities for something to go wrong when we're doing that, which is not good. And I really wanted us to put a system in place to, after they were programmed, we have kind of like this little stylus jig that I made where like you have 5 pogo pins, you put them on each slot, you tap a button and it programs it and it auto increments the address. So it just goes up and you can bang, just program them all through. We did everything we possibly could to make it foolproof and no the best process is no process, but we need a process for this.
Yeah.
So we're resulting with, we have to do a QC check. So using the same jig, and I only had like 3% of flash left on the chip, so I had to do it. It was tough squeezing it in. I was like shortening my characters to be short in the screen to like, it was a lot, but I got it so that you can put it into read mode. And now we have a QC check with the exact same hardware to read in and display every address. So now we have a secondary process where we QC everyone, and it's great. It's absolutely awesome.
Yeah. Very needed.
Yeah, definitely needed. And it was like 30 minutes of work, reflash the hardware, and then magically now we have this new thing on that existing piece of hardware. We have this new feature built in. So it's nice to, that's part of the reason. This is also kind of going back to last episode of like building your own equipment or buying it. Like building your own, you can just bodge something in like that. Like I took 30 minutes and I added a whole new feature to a piece of hardware that I built a year ago. You know?
Yeah. If we'd asked a vendor to design that programmer jig in the first place, that would have been $5,000. And if we'd asked them to update it for a new software feature, it'd be probably 2 months and $2,000.
Yeah, but it took me 30 minutes. Yeah, and it was free.
It's great.
Yeah, it's a good way to do it. So, you know, having your QC jigs in house, it depends, but I feel pretty strongly that it's good to do that. Like I think about our time at Formlabs, and like so much of the QC stuff Formlabs made. It wasn't a vendor. Hell, that was most of your job.
Yeah, it
was making that stuff. Like making QC jigs and understanding them well is so important. There's a great Bunny Huang article. Bunny Huang is just the coolest dude. I look up to him so much.
I'd love to meet that guy.
Me too. He's so cool. But he has a really good blog post about how there's actually two products when you make a product. There's the product, and then there's a product that tests the product.
Yeah.
You have to design it. There's a lot of engineering that goes into that step. That's ultimately what defines what you're shipping. You know, if it passes or fails a QC check, that's you're drawing the line of like what's acceptable to send out the door. That defines what you send, you know? So, man, it's so important. And keeping that in-house and having a really tight loop on what it is you're actually checking, I don't think it's a thing to outsource.
No, I even say it's so imperative to think about how something could be made wrong, how something could be tested at the time of product design.
Oh, totally. The best example of this is test points on the bottom of a PCB. You are literally designing into the engineering CAD file of the PCB the points that a pogo pin jig is going to interface with. Like, it needs to be thought about from the beginning, from the absolute beginning. Yeah, like debug ports, extra UART ports on a PCB. Like you're putting those things in to start just for making dev and checking easier.
It's exactly right.
Yeah. So now we get into actually designing how you do your QC check. And this obviously depends greatly on what it is that you're actually testing. Like we have a different methodology for thinking about how we design a test for like, does our X gantry move correctly versus like, is the motherboard soldered correctly? Obviously, those are going to be very different things. So in general, when we do design a test, we think about not just the worst case scenario, but the entire range of what's possible. And so like to help clarify this, like you might be inclined to test a gantry to only move the fastest speed you'd ever expect it to go. And that's a pretty reasonable knee-jerk reaction of like, let me just give it the worst. But your understanding of the worst may not be the actual worst. It might actually have some weird failure point at 1/3 the max speed. So my best recommendation here is don't make assumptions about the worst case. Test everything, especially if it's automated and it doesn't cost you anything extra. You can just run a test and let it go. Don't test the max speed of a thing. Test every speed of a thing, because there might be a failure you have not considered yet. There are things that you know, like I know my name is Stephen. There's things that you don't know, like I don't know the rules of tennis. And then there's things that I don't know, like I don't know the rules of Gloobity Glorp, the game that Martians play, because I don't even know that that's a game. I don't even know that exists. And those things, that third category, the things that I don't know, that's what you're catching.
That's where it's dangerous.
That's where it's dangerous, where it's like there are failure modes you haven't even thought of. We'd like to think we're catching everything, but we're, as you said in last episode, we're little meatballs. We have electric meatballs in our head. We're not computers. We're not going to catch everything. So testing the entire scope of what's possible and not just the worst case helps you catch those third category things of things you don't know that you don't know. You know what I mean?
Yeah. I would say on that, like, it's never regrettable, except for cost and time, to test extra, and you can do things for a while and walk it back.
Right.
Tone it down.
Oh, that's such a good point. Start with heavy QC.
Yeah, we definitely do that.
Yeah. And then if you're like, oh, this has literally never failed once. It's like, okay, this is obviously a waste. And especially if it's a QC check that it's higher up the line of it's early on in the process and it never fails, and we're still checking it before it goes out the door.
Yeah.
The only reason we're doing those earlier checks is to save us time down the road. If it never fails, nuke it. Get rid of it. You're still going to make sure something bad doesn't go out the door. You're just wasting time at that point.
For sure.
Yeah. So the best example of not just the worst case scenario, but a full range of things is the feeder accuracy test. So we run every feeder through. We have a camera and machine vision, and we check the position of the void in the tape. We don't just check that one feed is moving to the right position. We check the entire rotation of the wheel. We run it through a ton of cycles to make sure we're actually catching it. So we're checking the whole scope of the feeder. What are all the positions that those 32 teeth could move the tape to? Not just checking one.
Yeah, and from the production line perspective, it's frustrating. It adds a lot of time. It makes feeders stay in the building longer.
Yep.
But from the quality perspective and the customer perspective, imperative.
Right. Yeah, totally. And also another great example with feeders too is we don't just check with 0805 tape, the thickest tape. We check with the full gambit of thicknesses of tape for feeders too, because they have different responses. They handle differently in the feeder. We want to check the full range of things and not just what we think is the worst. But yeah, there definitely is it keeps things held up more. It takes a lot of time to check, but it's worth it. That is so much of making a thing. Making the thing is not really the main thing. It's making sure you made it right is such an unbelievable amount of feeling like we can put something in a box and ship it to someone.
Yeah, it's probably hovering around 10-15% of the total labor time.
Oh, really? I was going to say like 25.
I don't think.
You don't think it's that much?
I'm on average across our products, I think testing in QC is that 15 plus or minus 5% range.
I think that's fair to say. I think feeders are probably more than the lumen because, I don't know. The feeder tests are pretty automated, but it runs for a while. So I don't know. It's definitely, it's a double-digit percentage for sure.
Oh, yeah.
Yeah, it's a good chunk.
It should be.
It absolutely should be.
A quirk of it, too, is that we're in a considerably low volume, so it's just not worth paying for a robot to program all 50 slots at once and do it perfectly.
Right.
We have to really pick and choose, make a QC thing that's good enough, a QC process that's sufficient for the volume. We don't need to overdo it.
Yeah, 100%. Could I burn 2 weeks trying to set a lumen up to put the programmer head on a gantry and program? Yeah, I could do that. That's not going to give us a competitive advantage. That's not going to help us grow the company and get more things out to people. And that's not really solving that many problems when just do
Check
it.
it.
Yeah, it's that's not the most important thing to be working on. Is it a possible improvement? Sure. Is it incredibly low on the list? Yeah, it's way down there.
Oh, yeah.
Yeah. Another thing to think about for designing the test is making sure that your test always matches your actual usage. So in Gundam, our test software, we home at the set. We literally copy the exact settings on our docs page and in the OpenPMP config into what we send to the motherboard before we run the test. So we're doing it all at the exact same speeds that we tell people to move at, all that kind of stuff to make sure that when we're testing it, it is in that same thread. It's the same scenario as close as we can get to as what the customer is going to experience and not making assumptions about that. And you were talking about the weight too on the thing too.
Important even to mimic how much load is being applied to that gantry when you tell it to go home.
Totally. Yeah. 100%.
We even see variances you wouldn't expect. It's worth plugging in both gantries at once just to test one of the gantries because 2 motors on a stepper driver acts differently.
Totally. Yeah. That's a huge one. That one's super important. Yeah. It's just trying to make sure that it's as close to actual real life as possible is big.
Don't build the whole lumen and test it. But pick something close to analogous to that.
As close as you can. It really is feathering the difference between building up the whole thing, testing it, the full thing, and then tearing it all the way down and testing all the little units and just hoping that they work being plugged together. Neither one of those is good. You need to find the balance in between where you're checking all the subassemblies, you're making sure they all work together in a reasonable way.
Yeah.
Another big thing to talk about with QC is AQL, which is acceptable quality limit. It is a whole world in quality stuff that I dealt with a lot when I was on the sustaining team at Formlabs. And it's effectively a way of saying, hey, if I have 10,000 units, if it's a critical to operation thing, I can check this percentage of my things and I have this percentage confidence that they're all correct. And if it's a moderately important thing, and they have all these ratings and stuff and all these lookup tables you can do for it, it's a way of checking millions or tens of thousands of a thing to make sure that there isn't a batch that's bad. This is really good for batches, but it's a way of it's sampling your testing. And then if you see a couple samples that are bad, that's when you start looking into things a little more.
Yeah, and like inspecting one piece in a batch you'd hold up the whole batch while you test that one piece. And if you see an issue, that batch gets held and then it's examined under a higher level of scrutiny.
Right. Yep. And so this is typically, in my experience, this has been used more for like after you get your FAI or first article inspection of a certain part, you'll do 100% testing for a while. And you'll make sure that things look inconsistent as time goes on, as you're like breaking in the mold or whatever the hell it is that you're making, things are consistent. And then once you're at production, if you're making 10,000 of a thing a month, there's no conceivable way to check every single one of those like with a person with all the quality you necessarily want to have for certain things.
Yeah, people will get lazy.
Yeah, people get lazy.
If you can even afford that.
Yeah, I mean, there are some things where you just can't do that. I think about Formlabs cartridges.
Yeah.
They just made so many of them.
Your favorite.
Yeah, I've spent a lot of time working on cartridges.
You want to tell us a bit about what the quality you saw there?
Yeah, so like they were all made, like there was a mold for them, and AQL was totally fine for it because we made so many cartridges.
Yeah.
And AQL was great because things would only change within a batch. It's not like one cartridge was bad. If there was a problem with the mold or like the operator on a given day put in the wrong settings, we'd see it in a batch. So we would always do things based on batches. We would do an AQL plan for a certain batch, and we'd use that to like hold up a certain batch or something like that as QC before stuff would go out. And that worked great for something that was inexpensive. We made a ton of them, and 100% QC checking was not really an option. So if you're making a lot of those little things, it's tough to say, like, first, like we do 100% testing on everything we do. We don't even dream of AQL. Like that's just so not even a thing we're even considering. The other great example of this is Ben & Jerry's. Ben & Jerry's.
I didn't know about this until you brought it up this morning.
Yeah, it's so cool. Ben & Jerry's has a really QA/QL process where for a given 2-day period, they only make 2 flavors of ice cream. They have 2 or 3 lines at their facility in Vermont. And for those 2 days, they just run 1 flavor. And it's like the batch that they kind of like set up, they load everything in, they make that batch for those 2 days, and then they swap it over and they make a ton more of a different flavor because it just takes so long to set up the line. It's kind of cool. Interesting way to do it. What they do is I think it's like every couple hundred pints of ice cream, they take one out of the line and they run it through a bandsaw. And they actually have a process for checking, like, in this cookies and cream pint, how evenly distributed are the cookies? How many cookie specks do I see within this? Like, I mean, they literally have like QC metrics for like the cross section of a pint of ice cream. It's so cool.
I would have such a hard time keeping a straight face in that quality meeting.
You can watch them do it. If you ever have an opportunity, if any of y'all are ever in Vermont, they give factory tours. It is so cool. It is awesome to see how they do it. But then they do this QC check, and then they AQL sample. And for ice cream, that makes a ton of sense. Is it evenly distributed? Is the mixing happening correctly? Because if it's on one, and you know what happens if one is bad, they nuke the 100 before and the 100 after.
Right.
And then they keep on with it. They do a process tune and they go from there. AQL makes a ton of sense for something like a Formlabs cartridge. And when I say cartridge, I mean just the like blow molded frame. I'm not talking about the actual resin. That's a whole other thing. But the ice cream, like things like that really work well with AQL. Or something like a desktop pick and place machine. No, you're doing 100% QC on every part in that.
Yeah. At my time at Formlabs, I saw AQL a little bit differently. It was the quality engineers would have an inspection process for the material that came into the production line from the supply chain. Every single item had a different like AQL lookup.
Yeah.
So it definitely is a big part of supply chain. And with even the vendors know what level of scrutiny their parts are going to be held to, like what it needs to pass.
Sure. Yeah. 100%.
You don't expect your vendor to deliver. It's really expensive to require them to deliver 100% perfect stuff.
Yeah, totally. You're going to expect some small point percentage of something that's defective in some capacity.
Yeah.
Otherwise, it's going to cost way more. It's just not pragmatic to ask them for that. Because then you say, hey, there were a couple that were bad in this batch when you reorder, and they're like, cool, and they throw in a couple extra. Like, that's the best way to handle it, really.
For sure. You have to get kind of big before AQL becomes the phrase you use daily.
Yeah, you really do. Like, I would suggest that no one even really thinks about that for a very good long time. Like, you have to be big. You have to be making, like, so many of a thing. It has to be not a complicated thing. Like, if there's a circuit board involved, I would be like, no, you should do 100% QC. Like, I just don't think you should ever AQL something that, like, has any moderate amount of complexity. Blow molding is incredibly consistent. Ice cream production is incredibly consistent. And like PCB production is too, but like the complexity behind it, you just want to 100% check for that stuff.
With me, a lot of the time, I take a lot of assurance in like the commodity items we buy, like maybe GT2 belt or a pulley or a bearing or a piece of extrusion. It's so commoditized that it's scrutinized to hell by the first vendor in its supply chain, the second, the third. Like these pieces are transformed so many times that these products have been filtered multiple different ways for quality before they've even came to me.
Sure. Yeah. And, you know, I think about with electronic components too, like 100 nanofarad electrolytic capacitors or not electrolytic, ceramic capacitors.
Yeah.
They're just good. Like having a defective one of those is like the last thing I would check.
Yeah.
You know, it's going to be something else.
Or we don't need to check if an STM32 worked before it goes on to a PCB.
Right. I mean, well, that brings up another thing, which I think we should talk about later, of part validation.
Yeah.
Of like, what if it's a counterfeit? You know, what if it's got a different die in there and it's a repackaged thing? So like, there's some things like ICs, maybe a little different, but that's more of like sourcing them from a place that you can trust or valid parts. You're not programming the chip before you put it on per se, you know? But yeah, there's some things that are just commoditized. It's you get it and that's what it is.
For sure.
Screw.
Yeah.
for the most part. We've seen some weird screws.
Oh yeah. You can get really screwed up by one for one without threading.
Yeah. It's just like a rivet.
F.
Yeah, it's pretty weird.
But that's AQL. A good topic. It's another one of those where be aware of it, know it's out there. When you get big, know what people in that make a living in high volume production think about.
But definitely pump the brakes on it until you're at a big scale. Like if we filament, making filament. But even then, it's so cheap to just measure the diameter of filament as it's being made.
Yeah.
It's a thing for later. It's a thing to, exactly like you said. It's a thing to be aware of, but not to think about to start.
Yeah, borrow the processes when starting out, borrow the mentalities when starting out, but don't become a statistician.
Right. Yeah.
That brings us to, with QC, it's really important that you document this.
Right.
I think it goes without saying that people in your manufacturing line, or even just yourself, you need to have what's being tested documented so that it's done.
Yeah.
People on our production line aren't going to test extra things for fun or unprompted.
Right.
They're only going to look at what's being asked.
Everyone here is on a deadline.
Yeah.
We are trying to fulfill orders within a lead time. We are all hustling to try and hit that point. That is the mentality. No one is doing extra stuff. So it has to be required and written down in a formalized way for it to happen.
Yeah. Now, that's not to say no one would ignore the rail being blue when it should have been black.
Sure. Yeah, that's true. That's a good point.
But it's important. We need to be explicit and exact with our language and our guidelines so that things we care about most are examined and not glossed over.
Right.
If you go on ohi.opulo.io, you can see all of the QC checks we have for most assemblies. We have QC process flow written out for a lot of our testing procedures that involve Gundam-based systems.
Yeah.
And we have QC for our pack out. It's all written there.
Yeah.
So that we know that everyone's checking the same things. Everyone has the same techniques. You need to do it.
I think actually a lot of Gundam stuff isn't written down because Gundam tells you what to do.
Yeah.
You know, you run the test for the motherboard and it goes, hi, plug this in, do this. It walks you through it.
Yeah, it's definitely true.
Yeah. So I think a lot of the Gundam stuff is pretty undocumented. It's just run the Gundam check.
Yeah.
And it kind of passes it off there. But OHI's for all the kind of the simple, did I bolt this on correctly stuff?
Yeah. We innovate Gundam so fast that we don't bother showing you a screenshot of each pane because you're going to improve it faster than I update OHI.
Exactly. It's not worth it. It's duplicating work.
Yeah.
It should be the documentation of walking you through how to do it correctly. And if I'm not doing that, I'm not doing my job. It should be explicit on how to do everything.
For sure.
Yeah.
So the best process, you could say, it doesn't need documentation. It's just, you say, do the thing.
The process is the docs.
It's self-explanatory.
Right. Yeah. Which can be dangerous, but I don't think it is in this case. That reminds me of people who are oh, well-written code doesn't need to be commented because it's obvious what's on it. It's no, I think it's really important to help people along for that process. But the copy that I write into the windows that pop up in Gundam is the comments. That is the documentation. I'm saying what to do,
For sure.
Yeah. So yeah, I totally agree. Writing it down and making it explicit. And you say this all the time. No one on the line should be unsure of whether or not they made the thing correctly. We are dropping the ball if we don't have a system in place for everyone to know, yes, I did this the way I was supposed to because a system that you put in place told me. There should be no ambiguity.
No. And even if we put all those systems in place, it's still not foolproof. It's imperative we found to have a buddy system.
Yes. So there was one week where we were like, someone was out sick and we had a huge wave and we, during a short lead time, and like we were in a pinch to get a lot of stuff made, and it was all hands on deck. There was like 4 of us, like everyone at the company was in Ghidra building stuff for Lumens.
It was fun.
It was a fun day. It was a fun couple days. I think it was a few days we did it. And I was making cable chains for the machine. It was my first time having done it in like months. And oh my God, what a humbling experience to build a thing that I haven't made a long time. And like, I made the first design of the machine and I was struggling to build it. It was a great experience. It was a wonderful thing.
Butt.
So I got like a few in. I'm following the docs really meticulously that you wrote. Mm-hmm. And I think I made like 7 or 8 of them. And I go back and I look and I realized I had just totally skipped 3 steps for the last 5. I just did it wrong.
Yeah.
And I was paying good attention. I like to think of myself as someone who's attentive. I know what cables should go into the cable chain. I chose them. I know. But I still made more than 50% of the cable chains incorrectly. And I think what this is to say is like being snowblind to things. Like you do one thing over and over enough, it is impossible to not glaze over a little. Like that's just our electric meatballs are, repetition, cool, I can clock out. Like that's just how humans are.
Yeah. If you do a drive over and over, it almost feels like you teleport.
Right. Yeah.
And
you
it's the same.
Forget.
It's the same with building something. Yep. I don't fault people for skipping past something or making a mistake. It's inevitable when there's human hands touching this stuff.
Yep.
So intensely.
Yeah. It's really tough. And so then we added a buddy system to our QC process. And also, this is an important note here. Those cable chains that I made that were wrong, I QC'd them and I said they were fine.
Yeah, they would have gone out.
I looked at them. They would have gone out. But I think you double checked me. Thank goodness that you did. And you were like, Stephen, you just didn't do this for like all of these. And I was like, oh my, wow. It shook me to my core.
Yeah.
I was like, how did I miss this? But I had QC'd them.
Yeah.
So I think what we learned from some of those experiences is like, you will always scrutinize your own work less than someone else's. Because you're like, I already looked at this. I know it's right. You will miss your own mistakes. So we added a new system.
It was funny watching him build those drag chains. You 300% longer than anyone else would take to build one.
Oh, dude, I'm slow.
Yeah,
I'm so slow. You would hate to have me on the line, probably. Or you know what? Probably at first, I'd think I'd get faster, but maybe not. I don't know.
It's not for everyone. It's not for everyone.
You wouldn't hire me for the manufacturing team?
I think we could train you.
Fair.
But the buddy system's been really, it addresses what Stephen just pointed out, like that snow blindness to defects.
Yeah.
Your inability to heavily scrutinize your own work.
Yeah.
I found that no one's going to catch their own issues on something they'd made like that same day. Yeah. Maybe that same week. Maybe they come back to it a week later. It's like someone else made it, but it's still not the same. Like,
sure.
People may have so much confidence they did it right, or they always do this right. How could they forget it?
Sure.
And I don't care.
Yep. and when we find those things and we're like, oh, hey, it looks like you missed this. Anyone who made that thing, like me included, look, when I found those cable chains, I was shook. I was like, no, I did do that. Evidence to the contrary, pal. Like, no, you skipped it. It's not ever malice. It's always just like our brains gloss it over. Yeah.
Anytime I point out like an assembly defect to someone, it's like they're shocked. They're like, what? How did I miss that? I do that every time. Yeah. And that's why we needed a buddy to look over each assembly for a QC checklist. Mm-hmm. We have the assembler of an item and the buddy of an item review in each thing for the same criteria. Yep. And if it's good, then it can go get packaged out. Right.
Yeah. So we never have someone that built the thing QC their own thing. There's 3 QC checks that happen with every assembly. There's when they're building it the right way. There's the eyeballs on it the first time of like, did I make it the right way? Then after they're done building it, they do a QC check on their own work to catch if they miss something. And then the third one is the buddy, who's a totally separate person checking that same thing.
Yeah. So this is really like an example of like quality informing the process. Like, what does the process need to do in order to ensure that quality goals are met? Right. So for us, it means that the buddy is looking over the X gantry and the buddy is the one who's allowed to put it into the foam tray for shipping.
Right. Which implies that it's been QC checked. That's our method of tracking that.
Exactly. Yep. And sometimes the buddy is a robot. That's like totally fair game here.
Yeah.
The Jaeger jig that tests a motherboard is your buddy.
Yep.
It's telling you thumbs up, you're good to go.
Yep.
You can move it into like what we call a proverbial green bin.
Yep.
And if something's in a green bin, it's a buddy, whether robot or human, has looked at it and said, good to go.
Yep.
You don't need to scrutinize this further. You can just act like it's a commodity and ship it, sell it, put it into the next higher
Put it in
level
a stew.
assembly. Yeah, that's exactly it.
Yeah.
So we had the green bins, which was kind of useful. And then like yellow bins, you built something that's untested. Either a robot or a human needs to look at it.
Right.
When Lex finishes making feeders and he's tested them on Gundam, we still even consider those yellow because the robot's not checking if the right sticker is installed. The robot camera can't see the FIDs.
Right.
But that second person will come in and say, hey, good to go.
Sure.
I'm going to move it to the green bin if it looks good. And
So
then
it's
it can
like
get
it's been
packaged.
partially buddy checked because like the accuracy tests and like the communication on the RS-45, the buddy of Gundam has already checked it, but there's other things we still need there.
Yeah. And
Yeah.
if something fails, red bin.
Yep. Rework, QC, check them out.
Yeah. And if something's from the vendor, untested, unknown, white bin.
Yep. Or MRB
Yeah,
or something like that.
exactly.
Mm-hmm.
So
Yeah, the buddy system has been huge. It's been really, really good. And it also adds a lot of time. But like it always reminds me of like, oh, I'm so glad we're doing this when we catch something. You know, when I'm reviewing some subassembly and it's like, oh, you know, like OHI says this should have 3 clips, but it has 2. OHI says that it should be this screw put in this bag, but it's actually a different one that's going to confuse the heck out of a customer or something. Catching that stuff is like, oh, I'm so glad we're doing this.
and
You know?
exactly.
Yeah.
Something that's not immediately obvious but became really important here is it lets me chuck a new guy into the production line with far less supervision.
Yeah.
One of our new hires, Lex, he's awesome.
Mm-hmm.
He went straight to making feeders that were saleable his first week following OHI.
Yep.
And I didn't need to hover over him because the docs are explicit.
Yep.
And then the Gundam test software is explicitly checking the things we care about more than anything.
Yep.
And then I come in and I review them.
Yep. Based on the QC check. There's no ambiguity. It's all been written down. It's been explicit. Yeah, it's great. It's just like this easy method for anyone to pop in and help.
Yeah.
Yeah.
I even find like if I'll watch him build feeders as like our freshest like greenhorn team member.
Mhm.
And if I see him do issues, it's more easy to just update the docs and to like intervene.
Yeah.
He follows the docs each batch and I can just let these docs be my voice and it goes to everyone and the future next Lex.
Sure. Yeah, totally. Yeah, it's huge. It's a great way to do it.
Yeah. So always have a buddy.
Mm-hmm.
If you're building things for yourself by yourself, I'd say if you think something's done, come back to it in a day.
Yeah,
Go build something else in the meantime.
Yeah.
Like do pack out with fresh eyes.
I totally agree. Because otherwise you're going to be like, I made this right. Nope.
Yeah.
Doesn't count. Yeah, pretend like someone else made it when you're reviewing it.
Be reasonable here. If you're manufacturing like a Staples, that was easy button. And you press it and it says something, you know it's good.
That's true.
But
That's true.
if you're making something vastly complicated like the Lumen, fresh eyes help.
Fresh eyes help. It also, there's another aspect to this I'm just thinking of now where you say come back to it in a day. There's a lot of things where like we make it and it goes into a box and out it goes like pretty quickly.
Yeah.
Like we have a lot of firepower here of like a lot of very intelligent, efficient people making the stuff that goes into our products.
Yeah.
And there isn't really time to stew on it. And like, so we do this system with a buddy. But like when I did the glow tie Kickstarter for like a little light up bow tie 4 years ago, it took me 8 months, nights and weekends. I have looked at those boards spanning months and months and months.
Yeah.
I'm not missing anything because I'm reviewing it months apart. Each glow tie got my eyes on it, all that spaced apart. I'm coming at it with fresh eyes all those times. So if your batch production cycle, even if it's just one person, but it's over a very long period of time, you're kind of giving yourself that fresh set of eyes. You know what I mean? Like you look back at yourself 3 months ago, you're like, I don't know what that clown did. Like, let me check and make sure it's good now, you know?
Yeah.
And that helps a lot. Like I didn't have a single issue with any of the ones I sent out because I meticulously reviewed all 100 of them so many times. You know what I mean?
Oh yeah.
So that's another aspect to it too, is like, what's your cycle time? That's going to change things as well.
It's all tricky.
Mm-hmm. It's all tricky. We have talked about this quite a bit before on the podcast, but it definitely bears repeating because it's the whole point of it is Gundam, which is our internal testing software, which is something that I wrote in that all-nighter that I mentioned before, where we're like, we need to make a test for the motherboard after through-hole, but before mounting it, I made a crappy Python script effectively, which controlled Lumen motherboard over serial, and you made a panel with a bunch of actuators, and we would check it that way. And since then, I've refactored it and changed it and turned it into like a pretty great tool. I'm very proud of it and I like it quite a bit at this point now, that does all of our testing something smart. If it's not like, did I put this bolt in correctly? If it's like, is this, microcontroller talking to this peripheral correctly? If it's anything
Electrical.
Yeah. Is a computer capable of talking to it? We check with Gundam. And a lot of folks were talking in Discord this past week, in the Lumen Discord, about standardizing test software. And like, there really wasn't anything great out there. Bunny Huang, who we talked about before, makes him and Zobs, XOBS. Sean Cross is his name, but he goes by Zobs. They worked on something called Enclave, which is it's a method of like testing embedded stuff. It's kind of like Gundam, but like way more for low level embedded testing stuff. It's really cool. Definitely not what we needed. Like, I needed some flexible hot glue code to, like, I need to talk to a receipt printer. I need to talk to, a web server. I need to talk to a serial device. I need to have a little UI pop up. So I'm in the process now of like trying to remove all of our private keys for our database logging stuff from it and put it in a format that it's not absolute a nightmare to put out so other people can use it, because people have expressed interest in it. And I'm trying to think about Conkers in the Discord. He made this really cool web serial tool for talking to a different feeder over, I think it's over Photon, but either way, it rocked my world. I saw this like web serial. It's just like a website he deployed with GitHub Pages, and you can connect to a device over serial.
So
and like,
cool.
It's so cool. I'm like, oh man, if we could just host a website that does all our testing for us, then other people could also use it as like a diagnostics tool. And then we just log in with like an Opula password, and then it logs to our database. But if you just log in as a guest, you still have all these tools available to you. It'd be really cool. I'm curious if any of y'all have thoughts about, testing software, making something that's kind of standardized for something that has to be so specific to your product. How much can you really make a tool for this that's generalized for other people? I don't know. How much of Gundam is made because it's what Opula needs and it's not like what everyone else needs? You know what I mean?
Exactly. Yeah.
Yeah.
You get so abstract when you think about test software for PCBAs.
Yeah.
You need to test anything and everything.
Yeah.
Or like anything's possible to be tested.
Sure.
Like we need. Yeah. My mind's racing just thinking about all the variabilities that there are to it.
Yeah.
Like her synthesizers need to plug into a oscilloscope through the test jig to make sure that it's like a pure sine wave.
Right.
How do you ensure Gundam in like its most versatile like possible like existence just let you plug in an oscilloscope module? That's a lot.
Yeah, it's a lot, and it's tough.
But maybe it becomes an open framework. Once it's out there, it'd be really cool to see where the community wants to take it.
Sure.
Like where it makes the most sense to go.
Maybe there's an oscilloscope networking plugin that talks to that thing. And I think it's harder if it's a website with web serial, like I was talking with Thea about this like 2 days ago of like, she was like, oh, we'd have to make like some kind of like, not Chrome extension, but like some web interface thing to like make it talk. It'd be a nightmare. So I don't know. It's a tough problem. And I think that's probably why not a lot of this exists already, because it's hard to make a Swiss Army knife for something. Swiss Army knives are inherently not good at all the little things they do. They're okay at all of them, So it's a tough one.
We've had a lot of, we've enjoyed design constraints around making things. Like it helps simplify the problem and our considerations. Like Gundam starts as an open platform for testing like open source machines. Yeah.
Or serial devices. Like all of Gundam relies on talking over serial to something, and like it has webcam support too. So like machine vision will also help with that. And we have all that built out. So maybe we just constrain it to that. I'm not sure. I'm very curious what any of y'all listening have thoughts about this and how you might use it, or like what would you need in like a standardized open test software? You could like customize it for yourself. I don't know. I've been spending a lot of time thinking about it lately. So, and it's very relevant to this topic because that's literally all it is. It's just QC checking, testing stuff.
All right, so there's one very large beast left to conquer here, and that's traceability.
Yeah.
Traceability is a behemoth of a topic when thinking about quality control.
Yep.
And we're going to give a brief synopsis. You're going to get the spark notes of traceability, and we're going to go deeper into it based off your feedback, questions, in a later episode.
Yeah, and this is just going to be traceability in regards to QC.
Yeah.
But, so first of all, what is it?
I'm quoting a random website that will say it better than me. Traceability is the ability to trace a product's origin, movement, and history. And that also includes the subchild items of a product.
Right.
So traceability is about being able to know what went into something and what those parts are, where they came from, who made them, when they were made.
Yeah.
It's knowing about all these different attributes of a product and its constituent parts.
The example I think of is like, let's say I have a serial number for a lumen and someone says, hey, for this serial number of a lumen, what day did you accept the Y2 stepper motor? And we have a serial number for that stepper motor, and we have a batch number from our vendor. We have the day it was accepted. It's all serialized. There's like an ID for every single thing in there, which is extensive and usually completely unnecessary. It's same thing with GD&T. You have to choose where to do it. You know what I mean? Like where it matters.
Yeah. Like each box of stepper motors has a barcode for the production lot.
Right.
Each stepper motor in that box also has a barcode on it usually, or a scannable thing that tells you, sometimes it's a laser etched code that says what day it was made, what its unique number is. And like, do we choose to care about the serial number of the stepper motor, the box of the stepper motor, or maybe just the purchase order number that stepper motor lot came in on?
Right. Or even not that, like an M3x10 screw.
Don't give a crap.
We don't care what order it came in. Does the screw fasten?
Yeah.
That's what matters, you know?
There's different levels of depth you can choose to exert. You can choose batch level, lot level, no level, unique serial number for your parts, and knowing exactly what went into what.
The main reason to do this, and correct me if you think this isn't an accurate description of the reasoning behind this, is the reason to have good traceability is to have an ability to more easily root cause problems. So if I'm expecting that a random stepper motor might theoretically have a problem, having 100% traceability down to each individual serial number for stepper motors is going to be useful. But pragmatically, when we buy stepper motors, we buy them from a vendor. We do not make our own stepper motors.
Yeah.
If we have a bad one, if we know what batch it's part of, we go to the vendor and we say, hey, there is a bad one in this batch. And then it's the vendor's responsibility to figure out the root cause. Our motherboards, we care a tremendous amount about, we're responsible for root causing them. We have 100% traceability on our motherboard, on the feeders, because those things we're responsible for the root cause. If there's something goes wrong with one of them, I want to be able to trace back everything about that product to help figure out what's going on with it. So do you think that's that's kind of like the litmus test for like how deep your traceability should go, is like, how responsible are you for the root causing aspect?
There's totally different angles to this. I think that's fair for Opulo and companies about our size or smaller.
Okay.
But let's say we're Volvo, or better yet, Toyota. That's because this actually happened.
Okay.
Their brakes stopped working on certain cars. There was a case where like the brakes weren't working that well. They needed to get that car back, figure out the serial number on the brake module, and do a recall.
Right.
Again, similar to what you just said, root cause the issue, but it'll also let them manage like the liability of like who else is affected and communicate to those customers before they got hurt.
Sure. But it's still their responsibility to root cause it.
Yeah.
So that's why they have full traceability on those things, right? Like, because it's still, well, I don't know. It gets very messy because like, I don't know.
It's also like traceability can be legally required. Right. Even if it's arbitrary.
Sure.
Like, let's say we're a military contractor, like every single part that goes into a Chinook helicopter is serialized.
Yeah.
They need to be able to know what came from where.
Right.
Because if something fails, they need to figure out who to blame, whose insurance policy is on it.
Right.
And I guess it goes back to that root cause.
Mm-hmm.
But it can be immensely more important than just figure out what went wrong with that part. It's like,
yeah. If people's lives are at stake, like if I'm making a pacemaker, if we make pacemakers, I'm going to want to have 100% traceability on everything in that, because it's people's literal lives. Like, I need to know if like a batch of pacemakers had a bad chip or whatever the hell. You need to know that down to every single unit.
Yeah.
You know, and like you need to be able to look at the one that failed and go, what day was the chip in that pacemaker manufactured? Can we isolate the batch of chips? You know what I mean? Like, I think it also depends on importance of safety and stuff. If one of our vendors happens to give us a Y motor that fails after 10,000 cycles of, a full execution movement or whatever, no one's life is at stake. You know what I mean?
Yeah.
A replacement motor solves that problem, and it's also incredibly unlikely. But so it's also kind of like the risk trade-off. Like, if you really need to make sure that you're taking care of people's lives here, traceability is critical.
Yeah. And really like high-tech products where there's a large amount of traceable parts, I've heard it called like product genealogy.
Mhm.
Like, what are the unique parts that go into the thing, and like, where did they come from, and like understanding the origins of your item.
Right. So what I was afraid of happening is happening where we're just talking about traceability.
Yeah.
Because it's so interesting. So let's talk about it with QC.
Yeah.
So, okay. So what do we do for it? Like we do the things that are the most important that for us to be able to root cause. Like if someone has a problem with their, I don't know, their left pump, right? The pump for pulling the vacuum on the left head. I want to be able to have some understanding of like when we tested that motherboard, what was the test result? Like, what was the vacuum sensor pressure for that pump? Was it lower than normal? Maybe it was a weird pump. And having that data is really helpful for us root causing the problem with the motherboard. So we have full traceability, full serialization on all of our motherboards, all of our feeder boards.
Yeah.
For the individual parts. And then for other stuff, we have serialized like finished machines. And then we have a general idea of like what parts that we ordered that goes into each build.
Yes. So we know every time a customer gets a machine, we know what week their machine was made.
Mm-hmm.
We know what date range that was made. And for most accounts, we know what production lot each like component within the machine came from.
Right. So if someone was like let's say theoretically, the stepper motor is an easy example and also highly, highly unlikely, but whatever. If we have, we know that within one batch of machines, someone has like a couple bad step promoters. We know what batch of step promoters that came from, and we would be able to contact the other people. If we're like, hey, if you have a step promoter failure, let us know. We can get ahead of it. And we know who would be affected, which is really the value of having that level of traceability. But per step promoter, it doesn't really matter. So we don't check that.
It's expensive to have this granularity. If I want people to be cognitively aware of like, when did some item in the production line come in?
Yeah.
And use the oldest first. It's resource intensive.
Right.
If I reorder rubber bands because we're getting low, I'm just going to dump the new bands into the old box.
Right. Yep. Exactly. Because it's a rubber band.
Yeah.
but there's like, so when we do QC on these things, we have traceability for some and other things we don't. Like testing Y and X gantries and their movement and homing and all that stuff. We don't bother putting a serial number on every single gantry because what are we going to do with that number? We already know what week it was made. We already know who made it. We already know generally where the parts came from. Giving each one a unique serial, like batches are usually fine for most things. For a sub-assembly, it's usually okay. You're doing that for the QC process. So when we check those things, we put them into a pile of good ones if it passes, or red ones for rework if it fails. But with motherboards, we want that granularity. But picking that is hard when you're doing QC, like figuring out what do you actually care about keeping track of when you're doing your QC.
It also hurts that a broken motherboard looks identical to a good one from even a foot away.
Right. Yeah, totally. That's true. So having more granularity on it is helpful.
Yeah. If I pick test one, put it down next to another, I can lose track of which one was tested. But by having a serial number, you can just double check which.
Sure. So at first I thought it really mattered for complexity. Like if you have a really complex subassembly, it's good to have serialization and really deep traceability for QCing that part. And I think that's kind of true. I think it's a mix of that and how much information would you like when root causing the problem?
Yeah.
Like we had a customer who sent us an email about his vacuum sensor. I could literally go, based on his order number, I found the serial number of his motherboard. And I looked at the literal, when we ran Jaeger, I saw the reading from the vacuum sensor that his exact machine read. And I could read those values because we tracked that. And we ended up getting them up and running based on that information. Like it's so useful for that kind of stuff. So when it comes in handy there, oh, it's great. It's so nice. And it's, and for motherboards, it's also not that hard to add. We just print out a sticker that has a barcode on it. And then Gundam just automatically logs all the data based on that barcode. So like it's kind of free to add serialization when you're already using software to test it,
For sure. A lot more could be said about this topic, how to do it, how to execute it, when not to do it. But let's save some for later.
Yeah, I think it would be a whole thing to talk about later because our time at Formlabs, we had such interesting, like there's so many parts and so many of them have deep levels of serialization. There's all these different levels of traceability, like well defined of like how traceable is each individual part. It's so cool. There's so much to it.
Even the machine's firmware was a little bit dynamic based off of like what versions of a heater module are in something.
Right. Oh yeah, dude. Yeah, wow.
Yeah,
the
it got
dependency
really-
tree is messy.
And that's where like the genealogy topic comes into play. But we'll talk more about that later.
Yeah, I definitely would like to. I know you have a lot more experience with that than I do, so I'd really like to hear about how you experience that at Formlabs. I would dive into a subassembly when needed, but you had to contain so many of the parts and the traceability in the subassemblies because you were on manufacturing. I would pop into a problem area and solve a problem, but you had to be aware of the breath while it was being built.
Yeah, we were two sides of the same coin. We were both on the manufacturing team, funny enough, but I was line management and you were quality.
Yeah.
So we saw things at opposite ends.
We really did. Yeah, I saw it after people were having problems with it, and you saw it when it was being built.
Yeah.
Which is kind of funny.
Yeah.
I'm so grateful for our time there because I think we really got such a good spread of exposure of that. Like we really got a good lay of the land. If I could have picked 2 different jobs for us to have at Formlabs to get experience to help with Opula, I don't think I would change them.
Yeah.
I think I would still pick exactly what we
I just wish we had gotten you to China.
Yeah, well, I've been there for other things, so it was fine. It would have been cool to go see a line there.
Oh, yeah.
Maybe it's in the future for us here.
We'll see.
We'll see.
Yeah, I want to plot out on a map how many vendors we have in China and like where they are and like figure out like what a tour of China would look like.
Right, like Mitch's hacker trip to China.
Yeah.
Yeah. Oh, that would be it'd be cool to just do a vendor tour and like meet up with all the folks that like help make the stuff that goes into the Lumen. That would be so cool.
Yeah. That'd be quite a video series.
Yeah, take a note out of Strange Parts book.
Oh, yeah.
That would be so cool. It would be like factory tours, but only for what goes into the specific product. That would actually be so sick.
Yeah. We always, in our bill of materials, the stepper motor is the item, but like where's the rotor come from? Where the bearings come from? Like how deep does it go?
Right. It reminds me of that TED talk of that guy who did, he like built a toaster from scratch.
Yeah.
Have you seen this?
I haven't seen that TED talk, but I've seen it with like phones and radios before.
And he literally, he's like, I'm not even going to use modern equipment to like make the plastic. Like and to make the metal, he like literally went mining and refined it using all tools that he made. And like he made a quote unquote toaster from scratch and he plugged it in and it blew the circuit breaker and it was completely destroyed.
Yeah.
But it's like he went to go see what's the process for how all this is made. It's kind of like this, but modern.
Yeah.
The factories that make this
exactly.
Stuff. Yeah.
I saw a video clip of Buffett this morning. It was him saying, like, holding up a pencil and being like, not one single person on Earth could make this themselves.
That's
like the graphite from Malaysia, the wood from South America, the rubber from Brazil.
Yep.
Like the labor from another country. Like
we live in a society.
Yeah.
We really do. Everything that we do is based on the infrastructure that is around us. Yeah,
it's a built society.
It is. That would be a really fun series. It would be probably the most expensive YouTube video series that I have ever, because most of the time they're just free for me to make, aside from like a couple $100 in R&D.
Yeah.
But that would be fun.
If any vendors listening want to buy me a plane ticket, I'll bring Steven's camera gear.
That would be pretty cool.
But yeah, that's quality.
Yeah, that at least our thoughts on it.
Yeah.
I think that's kind of it.
All right, guys, that's it for this one. Thank you again for listening. We really appreciate it. Don't forget to leave a review wherever you get your podcasts. It really helps us out a ton. You can find Opula on Twitter, Facebook, and Instagram. Also, please don't forget to check out opulo.io and sign up for our newsletter where we write blog posts and do customer interviews with all of the people we know building open hardware. We also want to let you know that our next episode will come out a bit later because of the holidays, so we'll see you in the new year.
Thanks, guys. See you later.
See ya. No, I'm good.
Just tell me.
I don't need your tricks.